lesson 9, wide area networking. After that we have lesson 10, lesson 11 and lesson 12. 4 lessons left after this lesson today. I would suggest you to start studying or learning or reading this lesson 12 by yourself. Okay? This will be your self-learning lesson, lesson number 12. So let's look at the lesson number 9, wide area network or networking. How many types of networks you remember from this course? Wide area network is there in front of you. What else?
LAN.
Wide area network and local area network. Someone else said this earlier, this minute ago. LAN,
SAN.
WAN, okay. You said SAN, okay. What else?
MAN.
MAN. What is it?
Campus area network. Campus area network.
Campus area network. Okay. Okay. And anyone else from the back seat? Back row. Back row, anything else you would like to add?
What about the string? It's like what the military use.
That again defines either it may be WAN, it may be LAN, but it is secure.
Yeah.
Right? So WAN, LAN, MAN, MAN and CAN can be same, and you can't differentiate between MAN and CAN. Okay, for example, this college has a restricted campus, or you can say defined campus, right? You know what is the campus of this college. There are few buildings. The area is defined that this area belongs to Gwinnett Technical College. Okay. Have you seen Georgia Tech or Georgia State University campus? Right? How do you find it different than this college? Anyone who has, if you have seen Georgia State University campus or the Georgia Tech campus, then those campuses are different than this campus.
In the city?
They are in the city.
Yeah.
They are the part of city infrastructure. There is no defined boundary or area that this area belongs to only Georgia State University and all the buildings inside this area belongs to Georgia State University. It's not like that. There are multiple buildings. Some of the buildings belongs to state universities, some are commercial, other commercial buildings. So if they connect all the buildings together, only those buildings which belongs to Georgia State University, if they connect all those buildings together, that will be your campus area network. But it also can be classified as metropolitan area network. But campus area network is, again, I would say smaller, is much smaller in compared to metropolitan area network. Metropolitan may be spreaded across multiple other locations, different. For example, if I have a network spreaded across the Lawrenceville city, only within the Lawrenceville city I have network. So that will be your metropolitan. LAN, you know, WAN we are going to discuss. What is WAN? What is WAN? It's body. It's body area network. Okay? It's body area network. The body area network, every one of us are carrying our own network with us, right? You have smart devices, smart gadgets in your bags, in your wrist, in your pocket, and all are connected with each other. That is your body area network. These days people are having a ring, watches, smart glasses, smart glucometers on their body, heart rate monitors. That all constitute or create our body area network. Now sand. Okay, sand is specific to storage only. These all are basically your network for carrying the data from one device to other device. But this is only and only created for and created by connecting storage devices together. That is storage area network. The devices we are using in these networks and the device using in these networks are completely different. The devices which are there in SAN can also be connected to some of these. Okay, your storage devices can be connected to LAN, can be connected to WAN, but SAN stands for where only the data which is supposed to be stored on the storage device, or the data which is stored on the storage device, you want to read that data, is basically covered by SAN. Okay, and in the SAN we do not use Ethernet technology, we use fiber. Okay, we use fiber. It's always confusing. We use fiber, I don't know, ER or I. Okay, so we use fiber for SAN, and a special type of switches we use in this. We do not use routers in this. Here we are using routers, we are using switches, we are using firewalls, so many things. This SAN can also travel on, the SAN data can also travel on LAN or WAN, but using a different types of protocol which is called FCOE. You will learn more about it in future classes. FCOE stands for Fiber Channel over Ethernet. Fiber Channel over Ethernet. So that means the data which is supposed to be travel on fiber channel or fiber optic cables is currently traveling on Ethernet network, which is made up of copper cables and all. So FCOE is another technology we are using in this SAN. So SAN is obviously it is a network. Oh, what is that? SAN is definitely a network, but especially designed for storage devices. Okay? Whereas all these different types of networks we are using. What type of cables we are using in these networks? CAT. CAT cable we are using in this, right? Huh? 6, 5, 7, 8, all those, right? All those categories. Now what is category? I don't want to remind you, you can search yourself. What does it category means? What does category means? Oh, cat means. Why we cat 5? What is the difference in cat 5, cat 6, cat 7?
Different generation.
No?
Independent distance.
No? Distance what?
So cat 5 can always hold up the cat.
Okay. You can find it, okay? That's not true. But don't worry. But I will suggest you to review or revisit all these lessons before the final exam, okay? I'm not giving you any hint that this may be a question, but you never know. I don't know what questions will be there. All right. So the In this lesson, we are going to check the compare WAN connectivity technologies, explain how routers manages inter-network communications, describe ways to secure WAN, and all that. So WAN is like connecting networks together. You have I-85. I-85 goes to your home. Does I-85 goes to your home? No. But sometimes you take I-85 to go to your home, right? So you take I-85, then you take some other streets or you can say state highways or state routes, and then you take some streets, and then you take some lanes and reaches your home. So I-85s like highways or freeways are connecting other streets together. Same as your WAN. WAN is your a network which is connecting multiple networks together. Right? In order to use the internet, you have to use WAN, or you will be using WAN indirectly. So WAN travels a significant distance and usually support very high data throughput. Not all businesses need the same kind of WANs. Factors include the following. All of us are using WAN, but none of us are using WAN directly. Right? We all are using WAN all the time, every time, because these days we all are connected round the clock on our phones. Right? Our phones are connected throughout the day, night, every time, and our phones are using a lot of services, a lot of websites. Sometimes the websites are running in the background, sending and receiving data silently. You never know about it. They all are using WAN. So though some of those WANs are for certain distance, these networks are wireless, but for the long distance or longer distance, these all networks are wired. Now the various factors which include or which can impact your data transmission on these WANs are definitely traffic load, budget, geographical breadth, commercially available technology. When you are traveling, you may travel by train, you may travel by road, you may travel by air, right? You decide based on various factors like how much budget you have, how much time you have, what kind of mode of transportation is available to you. Do you have car? Yes, you have car. Do you have time? Yes, you have time. So you may prefer to travel by road or by car. But you say, no, I don't have time, but I have money. So you may prefer to travel by. You don't have time, but you have money. So what mode of transportation you will prefer? Huh? Say it loud. Uber? Airplane. Uber or driving makes the same, right? It takes same time. Uber is not, as of now, Uber doesn't have flying cars. They may have sometime later. What I'm trying to say here is that you decide your network based on all these factors. How much data you would like to send? So is 1 Gbps is enough for you, or 10 Gbps is required? How much data? Then how much budget you have? What is the cost of 1 Gbps and what is the cost of 10 Gbps? If you want to do that, then take the last row. Huh?
I was thinking about, the internet services, when they advertise the GPS and how much you gotta pay per.
Yeah, definitely, right? So what is your budget? How much you can pay for your internet service? Correct? If you look at your service provider, mobile service provider, they are offering you different amount of data. Some are saying you will get 100 GB of data per month included in this cost. They may say if you pay $10 more every month, you will get unlimited high-speed data every month. Now you will decide based on. Syed?
Yes.
I don't mind if you want to use computer, but take the last row, okay? This Working here, tick, 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 distract me.
Sorry, sir. My mistake.
Then you will see geographical breadth. How far you want to send your data? What is your distance? You want to send the data to Australia all the time? Then you have to look for how much data you are sending, what should be the bandwidth of that for that data, how much time you want to send. See, all these are impacted when you are talking about replicating two sites. This is your primary, this is your secondary. You have 1 petabyte of data every day you want to replicate. Don't just look what you are using. Just look, get a bigger picture in your mind. Try to see how much data these corporates might be sending across the globe. Facebook, Instagram, Amazon, all those companies, big data centers, how much data they are sending or receiving across the globe from one location to other location. They decide on all these factors. What is more important for them? Is the data security more important for them, or the cost is more important? What do you think? Data security is more important for these companies, big companies, or the cost?
Security.
Security is more important for them. They already promised you means we customers, they already promised us that they are going to secure our data. If you start imagining what it takes when you use one particular service on internet, how much infrastructure may be required to provide that service on your phone or on your laptops or desktops, then you will start appreciating or thinking about all this. When now you know certain things about the technology, then I would say that you should keep asking these questions, either to yourself, ask these questions to yourself, or ask these questions to some AI tool. These AI tools are smart enough to provide all this type of information to you. So, based on all this requirement, we decide what is my requirement. If I say what is my personal requirement is either I am connected to college Wi-Fi, or I am connected to my home Wi-Fi, or I'm connected to my, let's say, workplace Wi-Fi, where I'm already having unlimited amount of data available at a fixed cost. Do I really need any data on my phone? Or if you look at your phone consumption, the data you have consumed provided by your service provider, AT&T, T-Mobile, Verizon, whomsoever you are using, just try to get the summary at the end of the month, how much you have used. Then you will realize what is my requirement. Okay, so keep thinking and keep asking those types of questions. And obviously commercially available technology, so whatever is available in your area, you have to consider that as well. If your area, let's say you are sitting at a remote location in Arizona, where there is no network except the service provider's network, AT&T or T-Mobile, so whatever speed you are getting, either it is 3G or 4G, whatever speed you are getting over there, you have to use that. There is no other option available. So whatever is commercially available technology you have. Or if you are going to set up a data center in the desert of Arizona, then you have to lay a cable, or you have to ask some company to put a cable all the way to the data center you are setting up in that area, so that you can get a better speed. So it always starts with the planning. What is my planning? How much data I would like to send? So what is my traffic load? How much budget I have? What I would like to spend? Is the data more important to me, or the cost is more important? what is the distance I'm covering, and whatever the commercially available technology I have in that area, I will do. Now compare the WAN versus LAN, which is very obvious. Now you should always look for comparison in terms of layers. What layer is involved in that network? So your LAN and WAN may differ at layer 1 and 2 of the OSI model. What type of data? Now, whenever we are talking about the protocols, you know protocol? So WAN can only support routable protocols, or the services which can be routed over a network or over the wide area network. There are certain services or certain types of ports which cannot go through the router. Means router cannot let those types of requests pass through. They will be blocked by the router itself. Means I can only use within a network, cannot go outside the network. So you will learn more about these types of services later if you are going for network specialist, or even if you are going for cyber security program. There are some classes where you will see what type of protocols we can route over the wide area network, and what can stay within the LAN. So certain services can only work within a small area network, and certain services can go across the network. So you will learn more about that later. WAN connections, broadband. These are the various WAN connection service options. So you have broadband services, you have dedicated internet access or DIA services. So you can read more about these services from in this chapter. DSL, digital subscriber line, which is related to PSTN, public switch telephone network. Very few people, those who are sitting at a very remote location, they are only using this technology these days. Otherwise everyone is having their cable network or fiber optic network or Wi-Fi or wireless network. Someone who is sitting in the Smoky Mountains, up in the Smoky Mountains, may be using this PSTN. Cable broadband, I don't know if anyone is still using cable broadband. There was a time when we were having cable network in our homes, and the cable broadband comes with that network. So these types of services are provided by different service providers in order to give your WAN services or provide WAN. WAN services means providing you internet services. That's basically, so your home will become a part of WAN. It's like that, right? So your ISP, your ISP is providing you the connection at your home. So your ISP is a very large network, right? I'm sure you know that. You can imagine that ISP is not a small entity. ISP is a very large entity which is making you means your home, making your home a part of or connected a part of some kind of WAN. Now the following trends in ISP offerings. So FTTC, the fiber to the curb. What is fiber to the curb? Means your fiber connection comes all the way to the curb side in your home, or you will get the fiber connections only up till the curb side, not in your home, but in your home it will be a copper cable or Cat 5 or Cat 6 cable. FTTH, fiber to the home. AT&T in the city, what I know, and Google also in certain areas, providing fiber to the home services, where fiber cable comes all the way to your home. So it is something like two things are there. So one is FTTC, where the fiber, this is your fiber connection coming, this is your curb side coming until this, there is a box installed outside your house, and this box is basically providing the connectivity to multiple homes in the area, right? Multiple homes are connected to the same box. You must have seen this. It's a very common type of internet service in the area.
It's above the ground.
Huh?
The box is above the ground.
Yeah, the box is mostly above the ground. You may see some green color box lying outside, or some cylindrical box outside your, it may be in the back side of your house, or it may be in the front of your house.
Are you talking about like that green box that as kids we used to go run and jump on?
See, you should speak louder.
As
if you can
kids-
hear my voice, then I'm.
As kids in the neighborhood, we used to see this green box, and we used to jump on it, play around it. It was like a
Possibly you may damage those connections if you want to. Means you can go and open that box and you may unscrew the connections. That's fine, yeah. You can do that. People, I'm living in a neighborhood which is newly constructed. The earlier neighborhood was the old one. In that neighborhood, all the internet connections were in the back side of the houses. Now this time it is on the front side. And because it's new construction going on, so it's off and on the problems keep coming, because they were digging somewhere and they cut the cable, and then the company comes in and then they restore the connections and all that. So until your connection, internet connection depends on cable, until your internet connection depends on cable, you will face all these kind of cable related issues. So I prefer to go for completely Wi-Fi, because that is the most secure way of keeping your internet connection alive in all the cases. Even if it is some kind of burglary going on in your house, where in the movies they show, first cut the internet cable, secure line or internet connection, so that all the cameras, security equipments can be disabled. It's a very easy way to disable all the security equipments you have in your house. What the cameras or the security equipments will do if someone cuts the cable, internet cable. Few months ago, I disconnect my internet at home, and I went somewhere else, and I was actually I'm using a Wi-Fi, T-Mobile Wi-Fi home internet. So I took that Wi-Fi router with me when I was traveling. So my home was out of network. My security company called me after 2 days. There were 2 days complete blackout on the security, and they called me after 2 days. They didn't call me immediately. They should have called me within an hour or 2 hours that your service is interrupted, there is no connection, there is no signal, there is no update and all that. So just imagine this, what kind of services we are using and what is the dependency. Now in IT infrastructure, if you guys are going to be connected or associated with IT infrastructure, then always look for something. Always look for something which is known as single point of failure. In our houses, we have lots of single point of failures. Our electric supply, how many electric supply connections you have in your houses? Do you know? Just one. Just one. How many internet service lines you have in your house? Just one. How many water supply you have in your house? Just one. So these all are my single point of failures. These all are my single point of failures. If that supply fails, I'm done, right? So, but in IT you cannot afford single point of failure. If your data center has just one power supply, cannot work. If your data center has just one internet connection or just one data connection for rest of the world, it cannot survive. If your data center has just one security system, it cannot survive. So data centers are, or not just data centers like this college, cannot survive with one simple one dependency on a dependency on one kind of service. So we should also use, or sometimes organizations use lease lines. Lease lines provide dedicated bandwidth. Means you always have a line reserved for you, dedicated. Sometimes like VIP movement. Have you seen any VIP movement on the road? When they block the traffic, all traffic from all the sides, and then they just have the free movement, and so that's kind of dedicated line. Do you have, or when do you need this? So there are many ways to secure the communication. The only thing is you must know your factors. These are the factors. These factors are the most important things. You just keep these factors in mind: traffic load, budget, geographical breadth, commercially available technology, and obviously the importance. If you are out of network for certain few minutes or few hours, does it going to impact you? Does it going to make a loss in your life? Let's say you are you just staying home, so it doesn't have any impact. So I'm not that dependent on that service. That's why I just have one type of service at my home. I don't have multiple services. I don't have dedicated services. I don't have any backup option available. How many of us are keeping gensets at our homes? Gensets in case of power failure, so I can use gensets. No, because we know that the service is so reliable. Even if it fails, it may fail for a few hours or few minutes. In a very rare circumstances, like some hurricane hit the area or some bad weather, because of bad weather some power lines got down, so it may take a day or two, not more than that. That's why. That shows the importance. And based on these answers you have in your mind, you decide whether I should have a backup or no backup. How many of you have cash in your pocket? Cash, dollars, bills. Only one, two. You have cash?
Yes, in my wallet.
Okay, that's good. Rest of us are dependent on card. That I have a card in my pocket, that is enough. But there are still in US there are certain places where card doesn't work, only cash. You have to carry cash. Then only you can pass, or you can do any business transaction. Anyways, so this is just a picture example. So these are other WAN related terms. MPLS, multi-protocol label switching. So MPLS is basically enables multiple layers, multiple types of layer 3 protocol of travel over any one of several connection oriented layer 2 protocols. So MPLS is basically a special set of protocols. A special set of protocols that can carry your data over a long distance. Now if I ask you, if you want to send a packet to Australia, I'm not talking about data packet, okay? Package from your home. Your friend moved to Australia. Now you want to send a gift to your friend. So will the truck carries your gift to Australia, or ship or air? It may be either ship or air. Truck cannot carry my packet all the way to Australia because Australia is not connected by land. So what I'm trying to say here is that whenever we are trying to send the data over a long distance, which may be across the country from east coast to west coast or vice versa, or across the continents, then there are special protocols we are using. So what happens in that case, my data is encapsulated inside those special protocols, MPLS. So MPLS packet is now carrying my data over a long distance. through these devices, internet devices. So whenever my data is traveling through a long distance, I will put my data, or my devices knows that this data is going for a long distance, so I should put it in the special packet. So spatially tagged data packets can travel over a long distance. These types of packets will not be stopped by any router or firewall in the way or on the way between your source and destination. So MPLS lets router functions more like switches. This saves times and reduces the latency. There won't be any additional checks. I would if I start talking about it, I will take you deep into this all. The moment you mark your packet, like this packet going to Australia, so your post office knows that this packet is destined to foreign destination, right? So they put those types of packages in a special box, correct? And it is going through air, by air shipping. They tag it air shipping. They tag the package as air shipping. Same as MPL is doing here. Spatial tagging to your data packet, so that it won't be interrupted in between. It won't be stopped or interrupted in between. Cloud connectivity options. So for any kind of cloud services, reliable internet connections or reliable network services are the requirement. Without having an internet, without having a network, can we use cloud? The answer is simply no. We cannot use cloud if I do not have internet, or if my service provider has no internet. So organizations generally offer the following connections option: internet and direct connection. Let's say you are sitting at home, right? You are personally sitting at home and working on a cloud, so you just need internet to be connected so that you can connect to the cloud, right? Just internet is required, and you are connected to the cloud, you can work on the cloud. But if it is a company where hundreds of people are always like to connect to the cloud, in that case, if I use internet, now imagine this, if I use internet, or if everyone is using internet in this company to connect to the cloud, then if I have 100 or 1000 employees in my company, I am making 1000 internet connections to this cloud service. 1000 internet connections we are making from this building to the cloud service. Obviously it is not wired connection, but logically you are making 1000 service connections to the cloud. So instead of doing that, what companies does, they get the dedicated line. They get the dedicated line from the cloud service provider to the company, and then everyone is now making a connection till this point only, not to the cloud service directly. Obviously, internally it is happening. Internally it is still happening the same thing. But you are not using the regular or general network internet infrastructure for making those connections. So there are difference in that. Either I'm using general infrastructure which is available for the common public to get the cloud services, or I have a dedicated line which I'm using, or my all employees are using to get the cloud service. So it depends what type of service you are using. And then VPN. We have talked about VPN earlier also, so I'm not going to discuss it again. SD-WAN, we also discussed about software defined network, or LAN, or SDN. So SD-WAN is similar to software defined network we discussed earlier, which is basically centralizing the control of networking devices to manage your network functions. So basically everything is controlled by softwares. No physical device is required or will be used.
Relies on abstracted and centralized control of networking devices to manage network functions.
Right? So SD-WAN is basically every aspect or every work of hardware devices are encapsulated in a software environment. Then you have wireless WAN. These days we are using, all our phones are connected to internet all the time. This is nothing but the wireless WAN. T-Mobile is providing wireless internet services, that is wireless WAN. There are other, your Starlink, what it does? It is providing you the internet services across the globe. It is nothing but the wireless WAN. So all these are, and then you have different generations like 4G, 5G, right? Currently most of us are using 5G. Most probably by the end of this year or next year we may have 6G. Those are nothing but the different generations of services or different versions of services where the speed is the most important factor. The difference of speed from one generation to other generation. Then you have the satellite internet service, which is I was talking about. Starlink is one of them. But it is not like only the Starlink is providing that type of services. There are other companies also which are providing. You must have heard about the satellite phones. Satellite phones are not the new things. Satellite phones are there since many years. And this is how the wireless LAN works. So you should have satellite somewhere in your vicinity, or the communication devices must be able to see the satellite or must be able to establish a communication link with the satellite. These are the various types of satellites, such as we call them geo-satellite link. Now, these satellites, they rotate at a speed where they look, they are not stationary, but they look stationary for a certain point on the earth. Or there is a series of satellites. So what Starlink is doing? Starlink is basically providing you a series of satellites where your communication device on the earth connects to at least one satellite all the time. So like this is your earth and you are sitting here. So you have series of satellites and your device is connected to at least one satellite all the time. If not this satellite, then maybe this satellite, or maybe this satellite, or maybe this satellite. So this device is connected to at least one satellite at least every time. So this is this type of so what the Elon Musk Starlink company is doing, they are trying to cover the entire earth with a ring of satellites. So that every person on the earth must have internet connection all the time and every time using their company Starlink. And even now other countries are also, like China is talking about having a mesh of satellites around the earth. Can you understand mesh? Like a net. They want to cover the entire earth by using their tiny satellites and having a communication channel or some similar kind of services like Elon Musk company is providing. Okay, now these are the routing protocols. So I was talking about MPLS. We were talking about MPLS earlier. So routing protocols are a special protocol which can be used to communicate or send the data over long distances or over WAN. So router joins two or more network and passes packets from one network to other network. And so these are all, you can read about the routing protocols, and you will learn more. Again, I am saying the same statement. You will learn more about these routing protocols later. You can actually control the network communication with the help of these routers and these routing protocols. Like what kind of traffic you would like to allow, or what kind of traffic you would like to deny, or what kind of traffic you would like to reroute to a different destination. right? So router performs following optional functions like filtering the broadcast permission, preventing certain type of traffic from getting, see, all these things. Now, routers cannot do all these things by themselves. These all are idiot boxes, you know. These all are electronic devices. They all depends on your commands. So you are going to configure those routers in real time in future when you learn more about those, and can control the network traffic or network transmission. There's the company called Next Horizon company like Verizon also is a part of that. These companies are basically managing the traffic across the globe. This is kind of backdoor or back end or a back office operation. They are sitting somewhere in this globe and controlling the entire traffic. Which is flowing from one city or one state or one country to other country. And they are managing thousands and thousands, or you can say millions of routers they are managing across the globe. So these are various types of routers like core router, edge router, exterior router. So what is the role and placement of these routers in the network? Right? So this picture also explains you what are the roles and positions of routers. So you can manage all of these according to your requirement. Routing table, which is very important. Routing table is basically tells you that what type of traffic coming from which side or which network or which IP should be going to which network. So routing table is basically establishing that if a network is coming from this IP should go to this IP network, or a network data traffic coming from this IP going to this IP. So you can basically redirecting your network traffic from one to other. It is like you are setting a direction for your data packets or for your network traffic.
Is the routing table built automatically?
No.
It's not.
Again, there are two types of routing tables we can have. One is you can set your routers to build their own routing table, or you can build your manual routing table. Okay? So routers are some types of, some level of smartness is there in these routers. They keep learning who is sitting next to me. Who is sitting next to me? So every port, this is port. Now imagine every port has an IP address. Every port has an IP address, and that port is connected to some network. That port is connected to some network. Just imagine this way. That port is connected to some network. So every network has an IP address range. So every router in this port, now this port having two IP addresses, one IP address belongs to this network and one IP address belongs to this network. This port, now tell me, this port has two IP address. So one IP address belongs to this network and one IP address belongs to this network. Now even two ports are connected to each other, that makes a network. Don't just say that, oh, these are just two ports connected to each other. How come it is? It is a network. Don't don't have this misconception in your mind. Whenever two ports are connected in a network or two networking devices are connected to each other, they creates a network. And if they creates a network, that means there is an IP address involved. But in router, a port is always having two IP addresses. One belongs to a local network, one belongs to a wide area network. So now this port knows that the traffic coming from this network, I should forward this traffic to which port? Either to this port or to this port or to this port. Who's going to set that? So you can manually set that. Or the routers can also build their own routing table. You can say, no, don't build your own routing table. It is me who's going to create your routing table. Fine. The router will not build its own routing table, only whatever you provide. If you let the router to build their own routing table, so they are going to route to anywhere. The traffic is flowing anywhere. It is like you spill the water on the floor and water is now going according to the slope on the floor. Or you have a hose pipe. You have a hose pipe. Now you know you want to take the water, which way you want to take the water. So you set. You want to set the routing table, or you want this router to decide their own route. It's up to you. So either it is automatic or it is manual. Okay? Here. So routing table. So this table contains IP addresses, net mask. So not only IP addresses. On the routing table you can also control that the traffic coming for certain service. Do you remember, anyone remembers port? Port. Like SSH
22.
22,
You got
Telnet
23.
23, SMTP.
25.
So all these are the ports and their port numbers, services and their port numbers. So on the routers, you can also control that if a traffic coming from this IP address belongs to this service, goes to this way or that way. That type of control also you can have on routers. Getting my point?
Yes.
So one service, one IP address. So on the same computer you may have multiple types of traffic. Possible. Correct? Possible. So now you can control on the router that this computer is capable of sending all the traffic outside or not. Let's say I don't want any student from this college or any person, whomsoever it is, any person from this college should be able to do SSH to any outside computer. Correct? You don't want. So what you can do is, you can restrict this port. You can restrict this port. So you restrict outgoing request of this port or for this port on your college router. So college has a main router sitting somewhere in the network. You can block at that router level that no request from inside the network can be entertained inside the network or even outside the network. I should not allow this SSH from outside the network in the college. No one should be able to do SSH in the college. So any request, incoming request or outgoing request of SSH should be dropped or denied. So this type of control you can do, and routing table is something which is working across the globe, and because of the routing table only I am getting all the data from any website on internet. So these routers are having a long routing tables. And you will learn routing tables in more detail if you are going for any Cisco class in future. And I would suggest that if you are, let's say, if you are becoming a network specialist, then definitely you should go for Cisco classes. Even if you are not, then let's say you are a cyber security major, then also you should know this data flow. Then only you would be able to do some kind of investigation. Then only you would be able to identify how the network or data is flowing in the network. Routing path. So there are two types of routing path: static routing, which you create. a network administrator configure the routing table, and the dynamic routing automatically calculates. I showed you one thing earlier. I'm sure I showed it in this class as well, though I showed it in other classes. What is this? ARP minus A.
Shows the MAC addresses.
This is what these MAC addresses are. These MAC addresses, all these MAC addresses belongs to this computer?
No.
No. What these IP addresses belongs to this computer only?
It's all these computers.
It's the interface.
Huh?
The interface.
My computer IP address is this 10.10.182.91. Huh?
Yeah.
This is my computer IP address. Do I have this IP address in this list?
It's in the interface.
Huh?
At the top.
It's here only.
Yeah.
So what it is showing? What this list is showing? Huh?
All these.
All of these, all the other computers in this building, in this college. Why? And this computer knows the MAC address of all the computers. How? This is called automatic routing. This computer, when you go to the public, what do? You just keep your eyes closed and walk? No, you just stare other people's as well, right? You try to see if you recognize someone, isn't it? These computers does the same thing. They keep asking, hey, who are you? Who are you? What is your IP address? What is your MAC address? What is your IP address? What is your MAC address? And they build their own table. They build their own table of IP addresses and MAC addresses. So now every computer in this room or in this building or in this college has this type of table. And this is only at the computer level. Just imagine the same thing happening at the router level, where the router is connected to hundreds of other routers. And if I leave it on automatic routing, then it will build something like this. So now the router knows who is sitting in my neighbor. What is the benefit? Benefit is if the network request comes into the router, so router will check where should I send this request. Router will check where should I send this request. And then router is going to check the table. This is incoming IP address, and this column shows outgoing IP, connecting IP address. So incoming IP address should connect to this IP address. Incoming IP address should connect to this IP address. It maintains the list like that. Incoming should connect to this. Incoming should connect to this. Just imagine, how do you reach your home by using GPS? How does it connect road by road to your location? Something similar. They are using the names and the connections. They have hundreds of combinations with the connections like this, and using those connections, using those combinations, they give you a route. Same as routers are having all those connections already stored in their database, and when you are sending a traffic or data to some destination, it goes on, it is going, so it is started. So you are sitting here at your home, it is going to your ISP, then it is going to some other router, then it goes to other router, then it goes to other router. And these routers may also be connected to multiple other routers at the same time, but it is not sending to those routers because it knows what is the path required for this connection. It keeps on checking who knows about this path, so they keep sending the data or the request to that router only, and here is the destination. Now once the destination reached, it will send the response back, so it will follow the same path and reaches you. It's very deep. It's very deep. I'm saying, but it may not possible for you to imagine something like this right now. But definitely when you learn more about this technology, when you go more deeper into this, one day you will connect. One day you will be able to connect everything together. Just imagine this way, that the computer which is sitting here has the list of multiple computer IP addresses and their MAC addresses. Then if a router is sitting in a network which is connected to thousands of devices in the network, then what it may have. Right now I don't have, let's go and check on Google. Example of routing table. One example. So a network and a subnet mask, next hop. Next hop means who's the next router or next device. Then similar, the port number. Right? This is very small, very small example. So what it is showing? It is showing the breakdown of the entry here is that this is your destination network, this is your administrative distance. Here this is your one entry or the command you are going to add. So destination address and the via means through which port IP address if this traffic should route or should go. It's difficult to understand right now, but definitely when you learn more about it, you will get to know. For example, this picture. You must have created this picture on Packet Tracer, didn't you? Two switches. There were two switches, one router, two computer. Here you have three routers and two computers. Now, if you want to send a message, so this is your IP address, this is your neighbor's IP address. They are distant apart. You are sending their data to this. So how it is going to? So every router learns about the connected devices. So this router will learn about the connected device. This router will learn about the connected device. So when I send the request or message to this router knows that what other path is available for this particular IP address, what path is available. So it goes here, then here, then. So each of these routers, there's a very simple network. Each of these router knows what IP address is connected to my one port. What IP address is connected to one of my ports, so it can route or send the message or redirect the message to that port only. So you can get that examples, multiple examples from the internet. This is your route command. We cannot use route command here because it is kind of blocked. So this shows you to view a host's routing table, or this is your ARP command which I just showed you on the computer, ARP -A. This is the route command for computer. This is kind of route command for computer. And if you really want to see the route, then it is your example of route command. What you want to see: print a route, add a route, delete a route, change a route. Then these are some options of this. And if you want to see clear routing table for all gateway entries, so when you learn more about it, you will get to know what it is. So basically this route command allows you to view your routing table. So I'm just using example of using route command in Windows. So you can just say route print, or you can say route add followed by what is your network IP address. Network, not the computer IP address. In route or routers, we do not use individual IP address. We always use network IP address. Remember, in every network, the first IP address belongs to network and the last IP address belongs to broadcast, if you remember that. So if I have 192.168.0.0/24, so the first IP address will be 192.168.0.0 will be the first IP address. So this will be my network IP address, and the last IP address will be 192.168.0.255. This is the last IP address. So first IP address and last IP address we do not use. First IP address always belongs to network. Last IP address always belongs to broadcast. So if you want to add a route, then you always say route add network IP address, mask, and what it is. It may be gateway. Right? Gateway. Then it is your route P. So let's try using route print if it prints anything. Right, so we have something. Route print. So it shows that this IP address or destination, if the destination is 110.10.180.0. Now again, is this a computer IP address? No. Remember, in the routing table, you will always see network IP address. When you are reading a routing table, whenever you are reading a routing table, just think that it is a network IP address, not the computer IP address. These can be your gateway or node IP addresses, but this is always a network IP address. Destination is always a network. So you will learn more about it later. Routing matrix. So let's. What is the time right now? We started at 10 o'clock. Okay, we still have a few more minutes and then we'll take a break. Routing matrix. So properties of a route used by routers to determine the best path to a destination. So router has so many paths. Now which path is the shortest possible path in this calculation? Shortest path first. If the shortest path is busy, let's say shortest path is overcrowded, shortest path is too busy, then your routers will give you an alternate path, something similar to your GPS. When you set a path to a destination, it gives you 2-3 paths and shows you the time. But in this case, it doesn't ask you, hey, which path you would like to use to get the google.com. It automatically uses one path. And how it calculates? So you can see how it calculates. Hop count. Now what is hop? Listen, what is hop? Hop is this, the distance between two routers. This is one hop. Okay, this is another hop, another hop, another hop, another hop. So this way you have multiple hops. Okay. So if right now I cannot use, I told you that you should use it at your home, because your home may allow you to use this command, trace RT command. Here I cannot use trace RT. If I say www dot vinitech.edu, let's say. Yeah. So now it is saying over a maximum 30 hops. So it is going to find the path for this particular website for maximum of 30 hops, and every hop means a router. So now we cannot say we cannot use this command here, but maybe at your home you may be able to use it. So these means it is trying to connect to a hop, but hop is saying no, I cannot reply to trace RT command. That's why you are getting, or we are getting, request timed out. So routing metrics are hop count, theoretical bandwidth and actual throughput, delay, latency, potential path. So these all are the factors. Based on these factors, you will get a path. And obviously, other factors are there. MTU, cost. Now, what is cost? Cost is not in terms of money. There is a specific value assigned to a particular route. See, it is a route. This route has some value 1. This route has some value 2. Has some value 3. 1 again. This one 2 again. 2 again. It could be anything. Now, who assigned this value? It depends on where they do themselves. Means these routers, they talk to each other and they assign some value to their path. It calculates this cost. What is the cost of this path? And reliability, topology, all these are the factors which are involved in deciding the path. And these are then we have some routing protocols. Obviously, the routing protocols are also used. Whether I am going to use which mode of transportation you are going to use for the travel, bus, car, train, aeroplane, ship, whatever. Based on administrative distance, conversion time, overhead, all these are the terms we are using. Then these are some exterior and interior gateway protocols. That is most important in the long distance routing. EGP, exterior gateway protocol. IGP stands for interior gateway protocol. EGPs are used to edge routers and exterior routers, whereas IGPs are used for core routers and edge routers. Now these types of protocols are routable protocols over a long distance communication. And when you are working on routers, as an administrator, as a manager or configurator of those routers, you are basically working with these EGPs and IGPs. Now, EGPs and IGPs are the category or class of protocol. There are other protocols inside it. Inside these EGPs and IGPs, if you say examples of EGPs, exterior gateway protocol. So BGP is one of the EGP. Border Gateway Protocol is one of the EGP. IDRP is one of the EGP. Okay. Similarly, you can find some IGPs as well. RIP, not the one RIP you know about. So Routing Internet Information Protocol, OSPF, Open Shortest Path First. That's what we are talking about. Shortest path first. Open shortest path first protocol. These are the interiors and exterior gateway protocol. Oh, sorry, interiors ones. ISIS. Oh no, this is not the one which is operating in Middle East. Intermediate system to intermediate systems. IS to IS. Right? So it is again an IGP and the link state routing. So these all are the different examples of protocols you are using as IGP or EGPs, interiors or exteriors, and you can configure them as per your requirement. You can enable or disable them on your routers. Right? This is BGP again, the border gateway protocol. Is the only current EGP and is known as protocol of the internet. So the entire internet is using this protocol. Then you have this routing redundancy, active passive. Now all redundant resources are active all the time and work is distributed among them. Basically it is showing you if I have multiple routers, multiple devices running at the same time, then will it conflict with each other or will it work? So it is showing you active redundancy means all the resources are currently active and sharing. Active passive, only one is active, other one is passive, or few of them are active, few of them are passive. So it is then in this case your first hop redundancy protocol is used in this type of environment where you have VRRP, HSRP and GLBP are used. So again, these types of studies you will do in your advanced classes. You just here you need to know these terms or the use case of these types of protocols. How to secure WAN connections? So definitely with the help of these routers and these protocols, we can secure these WAN connections. And now there are hundreds of millions of, I would say millions of routers which are managed by independent bodies or independent companies. And basically whenever we are paying internet fees, whenever we are paying internet, let's say I'm paying $50 per month for my internet service. So a small portion from that fees goes to those companies which are managing those routers which are working for internet, because those routers does not belongs to any company. Those are not belongs to any company. Those are basically laid by maybe multiple governments, multiple organizations, just to keep your internet services up and running and secure. And obviously ACLs is one of the main way of securing your internet or network communication. ACL stands for Access Control List, and access control list can be created. It is like you have a code entry in your home, right? Everyone who can enter in your house has a code, and if they press the code, then only they can enter. Or you have a biometric device installed in your home door. When you press your thumb, if your thumb is recognized or thumb impression is recognized, you will get the entry. So ACLs are something like that. What traffic can come in, what traffic can goes out, that all can be controlled by ACLs, Access Control List. And you can configure it in, ACLs can be configured on any networking device. Any networking device you can configure your ACLs. So we can check this here in right. So how you can check the ACLs on Windows? So you can go to the folder, properties, security, or the ICACLS command line tool, or get ACL. So let's try this. This command. Right, so this is a command ICACLS. You can use this command to display your ACLs if there is any ACL configured on this computer. So ACL is basically a kind of permissions. You grant permissions to different users and services. Which service can access your resources and which service cannot. And you know what is the rule of thumb? The rule of thumb is, for everything we always have a rule of thumb. Rule of thumb is deny all, allow some. This is the rule of thumb in your network. For any security configuration, this is one thing. So the moment someone asks you, hey, create the ACL or configure the firewall, so the moment it's asked you configure the firewall, you say deny all, and now you will say, okay, let me know which one should be allowed. Right? So only those who has the code can enter your house. Otherwise, no one else can enter. So it is like deny all, allow some. All right, let's take the break.